Hello, everyone, and welcome to this auspicious, long-awaited event, the grand finale of the presentation of 2021 cohort. I am Precious Eureka, a data scientist at Hamoye AI Labs, joining from the city of Lagos, Nigeria. It will interest us to know that over here in Lagos, we are experiencing a rather cloudy weather with a bit of sunshine. And with this presentation, at this time and weather, I can confidently say that we are up for an outstanding afternoon. I'm pleased and indeed honored to welcome you again to the first half of the grand final presentation of the Hamoye Data Science Internship of 2021 cohort. At the start of the internship, we had over 4,000 people signed up for the internship. As part of the internship, the interns had to choose one of the data science, data engineering, and of course, the data storytelling tiers. I'm sure that a lot of you will agree with me that at first, it wasn't easy settling into the program, but as expected, we got a hang of it. Even though everyone has been working on different projects and learning from different perspectives, the vision has always been one and the same, which is building the future of work. Interns have started off on an amazing foot, problem-solving paradigms in short. You can see some of what we've learned, and I'm very, very interns who were very early with us. I'd like to acknowledge the person of BK Akimbo, Kingsley Lawani, Kennedy Uche, Louis Oge Triumph, and so many of you guys. I really appreciate you guys, and I'm thanking you for your enthusiasm to join early. I would like to call on anyone, if you would like to speak for a few minutes, just put your hands up so that I can call you on. So without wasting time, let me call upon someone, Kennedy Uche. Are you there? Can you unmute Kennedy Uche to speak? Or it is a way, okay, let's get on to Oge Triumph. Okay, are you there with us? I think everyone is a bit of shy this afternoon to speak. Okay, so what we want to do is we just want to hear your shout outs. We want to hear from you to know how this internship has been. We know it's been very fast paced, and most of us during the beginning of the internship, we had lots of challenges. So we'd like to know how far you've gone and what's your conclusion, or like give a summary of the internship. So someone.
Hello.
Okay, so we'll just move on since everyone is shy.
Hello. Can you
I
hear
believe,
me?
oh, okay. Yeah, I can hear you.
Oh, okay. So
Yeah.
sorry, I lost you for like a second. You
Okay,
asked a
so
question.
how would you rate the internship so far? So, like, what would you say your summaries of your internship experience so far? How would you rate it?
Okay, so I would rate it based on my learning experience and not based on all the
Okay.
activities, because I didn't really attend all the activities. But based on my learning experience,
All
I'll
right.
rate it. I'll rate it a 8/10 because I learned a lot
All right.
throughout the few months. I really learned a lot. Like I did new things that I have not done before. So that's something that 8/10. I was able to learn at a fast pace and it was awesome. So yeah.
So would you at any point say you were probably frustrated because of the whole timing and everything?
Yes, I would say I was frustrated. First, at the first stage A, I was having my exams. I was having exams and I was battling with stage A. So the day I finished my exam was the same day for deadline of stage A. So after exam, I had to take the whole stage A course in that same day, finish the whole project in that same day because I didn't want to get out of the internship at stage A. So that was really hectic for me. I was really frustrated after submitting. I was like, anything I score, I don't really mind. Let me just do this. and submit. Then also it's the last
Yeah.
the last stage we just finished too. I was really frustrated because it seems like the data I was working on, I did not know what to do at a particular point in time. But then I figured it out after talking to people that we are in the same track. So I was able to figure out what to do. And yeah.
That's awesome. Thank you very much. Thank you very much.
Yeah.
We have also Oladimeji Williams. Would you like to say something about the internship?
Yeah, I would say the learning experience was awesome. I followed through every stage and every activity. And for me, I mean, I can say currently it is the best learning experience that I ever had. For the fact that there was no video content mandatory, it's really wholesome because I personally don't really have to burn data. But of course, I had so many reasons to burn data on YouTube videos. I would not say I was frustrated, but I was challenged trying. That was the first time I would have a tutorial on practical stuff like this with just only text. So I was challenged to watch so many videos in order to accomplish all the tasks, and it was very, very awesome.
Yeah, it was very, very awesome, I admit. So without wasting much of our time, we'd like to move straight up. So allow me, dear interns, ladies and gentlemen, to introduce our judges. First on our list, we have Charles Adetiloye. Charles is a co-founder of Mapping Code, and we all know Mapping Code is a provider of a consultative service and expertise for building and implementing large-scale distributed reactive backend systems, processing massive large-scale data sets based in South Lake, Texas. So Charles has well over 15 years worth of experience consulting and as well implementing large-scale data processing and in the AI and ML software platform across different industries, basically. He has previously worked with Lightbend, Twitter, Starbucks, and a few other startups and Fortune 500 companies. Thank you for joining us today, Charles.
Yeah, thanks for having me. Nice to meet you, everyone.
Thank you. Okay, we also have on our end Biodun Awijobi. Biodun is a creative technology architect, a cloud security leader, and an accomplished scholar. He is an academic researcher and cloud computing expert as well. Also part of his belt, he is a business strategist, a coach, public speaker, and an amiable mentor. Beyond's story is a proof of dreaming and achieving. He has ultimately risen above so many limitations in life. He currently works as a customer engineer at Google and an adjunct professor of cybersecurity at the University of Dallas. It's an honor to have you with us at the conference today, Biodun. Okay, if Biodun is not on, okay, we could move on. So I know most of you all are itching to get started and have our minds blown with your wonderful presentation. So I'd like to first state some housekeeping rules. The thing is, each group you're expected to make your presentation in not more than 5 minutes. Yes, 5 minutes. And also at the end of every group's presentation, the judges, they have the right to ask any questions at all. Then the judges will also give their recommendations at the end of the presentation. So I indulge you all to wait to the end of the presentation. Then if you have any questions or any comments, you could use the chat box and it will be attended to promptly. Then if you must speak, please feel free to raise your hand and I'll unmute you. And to the presenters also, please ensure your display name is your real name so that we can identify you easily and grant you screen permission. So without further ado, we would like to call on the first group, the Apache group. Presenters are Orina Tululope and Abiola Kingsley. Tululope, are you on?
Okay, I'm on.
Okay, so you have 5 minutes to present and the time starts now.
Good day, everyone. Good day, judges. Good day, Hamoye. Lawani Kingsley and Tululope Orina presenting for Apache. Next slide. Next slide. Now, the web has made the world a global village and has ushered us into the era of the social media era. And this has allowed easy access to news, articles, and content. But however, they appear to be a plague that is eating up the social media space, which is the plague fake news, and is capable of damaging reputation, instigating wars and coups. So how do we solve the fake news dilemma? Now, one extreme would be to avoid the use of social media and news altogether, but this is not wise. Or can we leverage on data science and machine learning to build a news classifier that can help us flag a news as true and untrue? Now, this is the goal of our project. Next slide. The goal is to build a fake news detection web app to help us know a news that is genuine and the one that is not. Next slide. Now, to achieve this, we got our data set from Cargo, fake news and reading data sets. So I hand over to my colleague Dolorina to walk us through the evaluation, deployment, and EDF phase. Thank you. Over to you, Dolorina.
Thank you very much, Abiola. Good day, everyone. I'm with my amiable judges. My name is Dorina Tolope, and I'll be continuing from where my colleague stopped. So we went through this particular workflow to get our fake news detector, and the following exploratory data analytics, text preprocessing, modeling, evaluation, and development. In particular, for the text preprocessing, we did text parsing, that is cleaning of the text, and then we ran it through a bag of words algorithm, particularly the TF-IDF vectorizer with n-gram models to get our text representation, which we used for the modeling. Now, the following libraries were used for processing as well, and to extract visualizations, which we're going to see right now. This is the word cloud, which explains the importance and the frequency of words in a given context. So for this, our particular context, we have Donald Trump, Hillary Clinton, people, United States, and this can give us an idea of what our data set is about, which is majorly about US political news. And we also made look on the different classes of news that we had, and we realized that most of the true and genuine news came from the political news and the world news. We went ahead to perform named entity recognition just to make a visualization and extract key names and entities that were present in the data set. And from here, we can see that Jerusalem is a geopolitical entity, Donald Trump person, Reuters organization, and more like that from the name. And then we see that we went through feature engineering to also draw more insights from our data. From there, we ran our EBA plot, which showed Trump as the most frequent word. And then we also had other words that related to the type of news that we are actually working on. We ran access through classical machine learning models, and also we used a deep learning model as well. We carried out model evaluation on these metrics: accuracy score, precision, recall, and F1 score. And this is the table for the model evaluation. And from this table, we can see that random forest classifier was the best classifier. Our confusion metrics showed also that random forest performed best, even in the presence of the deep learning model, although we might need to tweak the deep learning model for some time to get something that is better than the random forest model. We also trained word embeddings so that we can words that are close together and that are more similar. Then from there, we are going to showcase the application now. Okay. I'm wondering if there's a way I can share all my screen. Okay. So the model deployment showcasing for later. Kingsley, please help us with the conclusion.
Okay, well, because from deployment, we saw that building a fake news classification can actually help us curb rumors and, of course, the spread before it's wreak havoc on nations. And also, we don't intend to just limit these bits to US, but of course, we want to go out and source the data for Nigeria, India, and that part of the world. Thank you. Any questions, sir?
Please, you could leave your screen on so that the judges could ask some questions. Thank you.
Yeah, this is Charles. Can you go back to that slide where you have the named entity recognition?
Okay, I will go there now, sir. Can you see my screen?
Yes.
Yes.
I think it's up where you have them tagged and you identify each one by the context.
Sorry, I didn't hear you, sir.
Okay, where you have them tagged up and you basically annotated each entity that you discovered in a sentence. I think it's probably screen number 9 or 10 or something like that. Up. Just scroll up.
Okay.
Pop up. Yeah, right there, number 10. Number 10, yeah. All right. Yeah, so can you talk a little bit about how you built this NER and the challenges you faced while doing that?
Okay. For us to derive the named entity recognition, we actually had to first of all clean the data set, and after cleaning, we take it through the spacing library, which was able to help us identify the named entities. We actually also have a model that we were able to deploy for the detection of the fake news, but I don't know how to, I've not been able to share the platform right now. That's the issue I'm having currently. I think this up part, I don't know how to minimize it and then share from the other side.
That's okay. So in terms of how you basically detected the entity, this is going to work on a global news. Like everybody knows that Benjamin Netanyahu. Everybody knows all the objects that you've identified and all the entities you've been able to extract them. How will this work in a local news where you don't have all these named entities that are very identifiable? How do you train your model to be able to pick that? So let's say this is running on your local news and the name of the location you are is not that popular for it to be picked up in the purpose that they use for the training. How will you train to basically identify and tag this kind of entities?
Okay. Would have to have
yeah, I think any of your teammates can answer that as well. I don't want to put you on the spotlight, but for all of you that work together, if you want to localize this to a different context and not to a global context, like how do you train your corpus to be able to do that?
Okay, how we train the corpus?
Yeah.
Okay, like I said earlier, we first did pre-processing, which included the text cleaning. Then after that, we tokenized. And after tokenizing, we ran a bag of words model using the TF-IDF vectorizer, which helped us to get a proper n-gram representation of our text data. That's for the modeling. Then for this NER in particular, we just used the spacey library, which helps us to easily identify named entities, and that can run on most data sets. Then if we don't have the particular, let's say it's not common, we can also tune the spacey with domain knowledge in such a way that we go into the low-level API of spacey. And then we map those particular entities to what we know them to be in that particular domain. Then we can also visualize from there.
Okay. That's it for me.
I don't know if you have any questions, Mr. Abdul.
So yeah, I can unmute myself, and good morning and afternoon, everyone. No real comments to make here, other than now you've gotten to a conclusion. You should look into putting this together and writing your experience and have a blog around what you've done. But overall, good job. It would be nice to see what you really did behind the scenes, but since you can't share, that's fine.
Okay, I think I can show it now, actually.
Okay. If the
we have a video on it and I can get it.
All right, go ahead. Just do that.
Okay. Sorry, I'm not seeing it here. So sorry about this one.
So I think because of time, would have to move on to the next group.
Yeah, quick advice though, for every other person that will be presenting, why not just queue up what you want to present? So that way.
Actually queued it up.
Okay.
I can't find it on the sharing stuff now.
Okay, yeah, it's not queued up in that case. Let's queue up what we want to do so that we can just get going super fast. That's more for the coming over.
Can I play from my end, sir? Can I play from my end, sir? I think
you have 1 minute. You have 1 minute.
Yes, sir. Just 1 minute, sir, from my end. Let me just share my screen quickly. Okay.
Could you zoom in on it so that we can actually see it clearer?
Thank you. Thank you. That's awesome.
All right, thank you very much, the Apache group. So we're moving on to the LIB group, Chimene, Giles, Aso. So you're next.
Good afternoon, everyone. I'll be sharing my screen now. Can you see my screen?
Yes.
Okay. So my name is Chimene. I'm presenting for Group D-Lib. Our project is on mental health in tech workspace. So these are a list of the team members that worked on the project. The aim of our project is to develop a machine learning model that predicts the requirement of treatment to an employee for mental health illness. So why is our case study on the tech industry? We found out that the tech industry fosters a crunch culture where you need to complete demanding, tedious work in a little amount of time, which leads to sleepless nights and builds up stress on the mind and the body. So our project highlights ways in which employees can seek mental health treatment and the factors that also affect them seeking the help. This is the workflow of our project, started by understanding the project to inspecting the data, the analysis, processing, and then preparing our data for the model, and then performance evaluation before selecting the best model. So from our analysis, the survey participants, most of them were between the age of 23 and 45. You can see it has a larger percentage on the chart. And then moving on to the gender analysis, we see we have a higher percentage of male compared to female, and others. Others have to do with those that are transgender or lesbian, the others that don't identify majorly as male or female. And from this, we can conclude that we have a larger percentage of the male in the tech workforce. Moving on to the employees' family history of mental illness, it was seen that those employees that have a history of mental illness in their family were more receptive to mental health treatments and to seek for mental health treatments than those that they have a history in their family of mental health illness. And then we also discovered that when employers provide benefits such as health allowance and all that to their employees, it also encourages them to seek mental health treatment as opposed to those that were not aware if their employers provide the benefits and those that don't provide at all. Then comparing the company types, in large companies, you have more people seeking treatments due to the workload they face and other factors, as opposed to smaller companies. Then another factor that encourages employees to seek treatment is anonymity. If the employees are sure that their sessions with the clinic and all that are anonymous and will not be disclosed, it encourages them to seek the treatment as opposed to those that are not aware if the company provides anonymity for such benefits. Moving on to the processing of our data, we used label encoder to prepare data for the model. Then the other steps were scaling and splitting data sets and preparing it for the model. We tested our training data sets on 8 models, and we found out that 2 models stood out, the random forest and the neural network classifier. They had the same score for the accuracy, then went further to check the cross-validation area under the curve to check for the more stable model, and the random forest model stood out, getting a score of 89%. This is the success graph showing the accuracy of the different models. And then we have the summary of the random forest, which was the best model, the confusion matrix, and the ROC curve with the area under the curve. Lastly, we have the feature importance, the features that contributed more in the model, contributed more to the prediction of the model. You have the age of the participants, the gender, and the third highest was the family history. Thank you.
Thank you so much for that. Okay, so on to our judges.
Quick question. Can you backtrack? What are the key indicators of the fact that someone might have mental health stress? I didn't catch the last part.
Sorry?
The key indicators.
Okay, the key indicators, we have the age, gender, and family history. Those are the top three indicators that an employee might seek mental health treatment or might have based on the family history, if it has been occurring in the family, or the age of the person due to accumulated stress on the mind and the body.
What's the average age?
The average age, I can't say the average age for that, but from our analysis, age range that filled the application was between 23 and 45.
So did you analyze the distribution in terms of what age group most likely will be subjected to a lot of mental stress, and probably the company or organization needs to pay more attention to?
Okay, from my results, I will say the companies pay more attention to the elderly age, let's say between 35 and 45, the right wing of the distribution, because at that age, the body begins to reduce in performance, so they are more susceptible to the mental health illness.
Okay, and what about the gender?
The gender, I don't think the gender affects or I don't think the gender has a major role to play in the mental health illness. It depends mostly on the kind of work the person is doing and how much rest and relaxation the person is getting.
So why did gender come up? Because what you're saying is like if someone is of a particular gender, they're more likely to. Am I interpreting these features wrong though?
No, the gender analysis was based off on the data sets. It showed that there are more males than females in the tech industry, and the gender column for the feature importance here highlights that according to your gender, as opposed to the anonymity and the work interference we have at the other end of the distribution.
All right. Ben, can you go back to the model selection? How did you go about the process of selecting the best or the optimal model?
So after the initial fitting and prediction, we used the accuracy, but the accuracy was not good enough. So we did cross validations of different parameters, and we checked for the area under the curve for each of the models. Reason being that the higher the area under the curve, the better the model is at predicting true positive and true negatives. So from the results, the random forest came out on top. So we selected the random forest as the best model.
And how many iterations did you run before you came to this conclusion, or you just did one iteration for each of these, and you just came to the conclusion that random forest is the most accurate or the best performance? Do you use any model selection criteria?
Yeah, we used the N ISA, we used about 100 for each of them. So 100. Can you hear me?
Yeah, I can hear you. Yeah.
Okay.
Oh, are you saying something? Or?
Okay, no, I said the iterations, we use 100 iterations for each of the models to select the best parameters.
Okay. All right. Thank you. I don't know if Wally and Dara have any question.
Yeah, so the data set that you used and you analyzed, what region were the data collected for specifically?
The data set was collected from different regions, but in our analysis, we found that most of the participants of the survey were from the US. So we dropped other countries because they had a little percentage to the data. So basically our model was based on the data from the US.
Okay. So what would you call the limitations of your analysis? Like if you could have it a different way, what would you have done?
If I could do it differently, more like getting equal percentage of survey from different parts of the world. So it's not really restricted to just one country or one region. So you get from like different continents that are into tech, an equal percentage from each of them. That will give a better model and better data set.
All right. Were there specific trends that you found in specific years? As an example, 2019, 2020, 2021, relative to the years or 3 years preceding that? Were there specific trends that you saw with your analysis or not really?
Regarding the trend, I didn't check for the trends for specific years because the data was limited to I think 2014 or 2015. So I didn't have data sets for 2018 or 2019. So no, I didn't check for trends.
Okay. Yeah. The reason I brought that up is I think that might be another limitation of your study. Looking for data sets that can tell a longer story or a more comprehensive story will be a good idea. But overall, good job. Thank you.
Yeah, good job, Chimene. So we're moving on to the Keras group, where we have Oladimeji Williams. So you could. Do we have Oladimeji Williams with us? All right.
Yeah, can you see my screen?
Yes, we can.
All right. Good day, everyone. Oladimeji Williams is my name. The title of my project is Mental Health and Suicide Rates. Mental Health and Suicide Rates. It is an analytical problem undertaken by Team Keras. These are the names of members of Team Keras. Well, suicide is a global phenomenon and it occurs throughout the lifespan of humans. Close to 800,000 people die every year by suiciding. This means that at least one person every 40 seconds dies every year by committing suicide. In fact, there are indications that for each adult who died by suicide, there may have been more than 20 others attempting suicide. So what caused this? We need to perform an investigative analysis on the global suicide rates and provide apt recommendation. But how are we supposed to go about this? This workflow process is a good guide. It starts by data collection, then prepare, clean, and fix null values and outliers. We then proceed to in-depth analysis using Python models and Power BI. Then we'll be able to draw valuable insights, which will be published on Power BI service. We got a near perfect data for this problem on Kaggle, and here's the link to the data set. On a global scale, we can see that as humans advance in age, they have a higher chance of committing suicide. This is evident in this data set collected over a period of 4 years, 2000, 2010, 2015, and 2016. We see that old people of about 70 plus of age had a whooping suicide rate of 32.2% per 100,000 population. This is evidently due to the fact that as life gets tougher, as we come to see its reality that all beds are not full of roses. But then let us dive deeper into the category of people committing suicide. Looking at 2016 being a pivotal and most recent year in this data set, we can see that globally, an average of 9.68, which is about 10 persons per 100,000 population of both males and females committed suicide. Specifically, about 15 males committed suicide, while about 5 males on average committed suicide per 100,000 population, which means for every 1 female, there are 3 females dead due to suicide. Why? Perhaps due to the fact that males generally are believed to be the breadwinner of the family and have to work in order to fulfill their family responsibilities, which cause them such a high mental stress due to high physical stress they had to deal with. So regionally, this chart here shows that Africa had a higher suicide rate for both sexes of about 11.39 on average. That is an average of 12 Africans committed suicide in 2016. Well, this is ridiculous because suicide occurred less frequently in African news in comparison with that of Europe and the Americas during that year. In fact, this chart here confirms the truth because many of the countries presented here with higher suicide rates are not African countries. But this chart here says that Africa as a continent had a higher suicide rate per 100,000 population. So why? We also find out that this is just a discrepancy and not a contradiction. However, this line chart here tells us that whatever the outcome, suicide rates declined and continues to decline every year. Remember the question raised in the previous charts, that is why Africa as a continent had a higher suicide rate, even though African countries had a fewer suicide rates. It is becoming clearer here. This chart here shows that Africa as a whole had a least average number of medical workers. This is also confirmed in this chart. No African country came close to top 10 countries with most medical workers. Similarly, these charts here show that Africa is provided with the least average number of mental hospitals. All of the foregoing, I prove that although Africa might not have had the highest suicide cases, yet they evidently had a high suicide rate per 100,000 population. We have seen the possible underlying reasons. One of such is that because they had the least infrastructures like hospitals and medical workers to respond to mental cases and thereby improve mental health. Therefore, I recommend that if Africa can emulate the rate of the availability of medical infrastructures in Europe and the Americas, Africa will definitely, in effect, reduce our suicide rate to the barest minimum of almost 0%, since life is precious, perfect, and invaluable. Thank you so much.
Thank you, Williams. So our judges.
All right, I'll start. So I'll just start out by saying that I really like your visualization, and a quick observation. It really felt to me like you you were reading off a script, or maybe you're just a journalist. It seemed to me like I was listening to the news, but that's fine. It made you more concise and precise with time. Are you reading from a news, or are you reading from a script, or not really?
No, not really. Not really. So I
Not
was not,
really.
yeah, no. I was not reading from the scripts. That was just a very good preparation. So I already had all my weapons.
Okay. All right. Yeah. But yeah, it sounded very sleek, but that's fine. From a visualization perspective, I thought you did very well. I didn't really see anything that you modeled in
No,
in.
I was just analysis, no model.
Okay, that's cool. Yeah, if you could go 2 slides back.
That's slide what? 5 or 6?
4, I think.
Okay. Yeah.
I'm referring to the slide that had Africans as the least population in terms of medical workers.
In terms of medical workers, yeah, medical workers.
Okay. Could you remind me when was the data collected, and what data range were you analyzing?
Please come again.
I said, could you remind me what data range were you analyzing here? Like what years were you analyzing?
2000, 2010, 2015, and 2016. That was the data I got from Kaggle. So 2016 is the most recent year. And not of the years had all features. So, but 2016 was a very good one to analyze, and the trends were very clear from 2016.
Okay. What were some of the data preparation or data cleaning?
Oh, well, so at first I was I had to clean. At first I was trying to predict, trying to model. In fact, I did a prediction. So I had to convert the number of suicide to, because I had number of suicide. So I had to convert it to percentage, and then use normal machine learning method to predict. But then I realized that it does not really fit the kind of data I had on ground. So it would be nice to just draw the insight from it. So in fact, I submitted one of the models I predicted, but I didn't really linger on it so much because it didn't really give me a clear picture, because the question was I trying to predict who would commit suicide or not? And then I couldn't find appropriate answer to that. So I just had to go ahead and just do the analysis based on the data I had. If I were to do it otherwise, I would have preferred more recent data, but then I couldn't get more recent data from Google. So I just had to work with what I had.
Okay. All right. So what was your biggest learning from this
Well,
project?
I learned a lot because it took me months. No, let me say it took me several weeks before I could come to this final conclusion of using Power BI, because I never had any prior knowledge, any solid prior knowledge using Power BI. So I was working with my Jupyter, but as much as I spent time on the Jupyter notebook, I couldn't get something meaningful. When I made predictions using the suicide number, it didn't really make sense to me. And I just had to watch some videos just to find a way around putting on my Power BI. And then I was able to get this 4 dashboards.
Okay. If you had more time, what would you have done?
Well, if I had more time, I would have scripts. I would have done a whole lot of maybe searching on the internet, did some web scraping in order to have many more data. Yeah, these data are huge, but then they didn't have the same number of features. And then And that was exactly why I was not able to use a machine learning model to make a good prediction. So I just had to work with the analysis.
Okay. On a final note, what would you say the conclusion of your overall study is? Is it all hinging on medical workers, or you think there's a little bit more that you haven't found out?
Well, according to what I worked with, it's just based on medical workers because we know that, well, let me say, for me, I believe that Africa does not really have high number of suicide. It doesn't really have high number of suicide, but the reason why the rate of those committing suicide in Africa per 100,000 population is very high compared to the Americas is because they didn't really have infrastructures to meet up to work with improving the mental health of those committing suicide. So perhaps if I had seen more data having many more features, perhaps I would have seen other trends, even if it is not just only medical workers and mental hospitals. But then with what I had, I would say it's just medical workers and mental hospitals. The fact that Africa does not really have many more, that was why the average is, the rate is very low. Of course, we can see it here that the average number of medical workers of Americas and Europe is very, very high compared to Africa. But then we'll come to the major trend here is saying that Africa had the highest suicide rates, even though Europe too had very high compared to Africa. So this shows that Europe actually had very high number of suicidals, but because they were able to provide so much facilities to cater for it, that was why Africa overtook them. So if Africa can have many more infrastructures, even if half of the infrastructures that Americas and Europe provide, of course, the number of suicides in Africa would reduce drastically.
As much as I would say it makes sense, I think there's still a lot more that we can unpack before we attribute it to medical workers. But overall, good job. I would love for you to think more into income. I would love for you to think more into other factors beyond income, cost of living. There are just multiple variables that could lead GDP of the country, all the countries. There are some European countries that are not better off as some African countries. There's so many variabilities that can come in the picture. Even medical worker is just a subset of just having a helpline. There's so many variations. There's like investments in mental illness. There's so many variations. But yeah, good job overall.
Okay, thank you very much. I also thought about all of those variables, but I wasn't able to get more of them. And I also thought even if there were those variations were present, even Africa had many more psychologists, they would have helped to talk to those people and stop them from committing suicide. But then, thank you so much.
Yeah, I would also love to know. I mean, the reason I asked about your data cleaning practices is what percentage of your data sets actually is representative of Africa? Because sometimes data can be confusing. You can, maybe there was a small subset of your data set that has Africa in it. And if the larger percentage were of other continents, you can easily make an inference of medical workers in here. So there are other data practices that you could employ to make sure that the number is well buffered. If you want.
Balanced. Thank you very much.
All right, Charles, if you've got anything I'm passing it on to you.
Yeah, I think overall it looks great. The question is like, what other options did you consider for the visualization beyond Power BI? You know, there's Tableau, which is not free, there's Plotly and all those things. So Power BI is good, but the thing about it is like, will this work in an environment where you don't have access to Microsoft products? You know?
Yeah, okay, yeah, I had Tableau. Yeah, I had. Thank you so much.
Yeah, now I was asking a question. What other options did you consider while building the dashboard?
No, I didn't think twice considering what tool I'm gonna use. I just thought about Power BI since it's one of the leading analytical tool, and then I watched video on it, tried to come up with this model. So I didn't try Tableau at all.
Okay. And do you have all this implementation checked into the repo in case you want to look at the code and how you design the Power BI dashboard?
Just come again.
Do you have all this checked in? Is there like a repository where you have the documentation of all what you did with the Power BI?
Yeah, I'm not written. I uploaded everything on my GitHub though. I've not written because I had issues with my laptop. In fact, it is not my laptop currently, so I had to move everything, copy, push it on GitHub, and then download here. So I had issues with my laptop currently.
I just want to see the implementation and the configuration you did. If it's something that can be grabbed, and I can run it locally to see the same results.
I really don't get the question.
I mean, the implementation that you did, is it all checked into like a Git repo where someone else can pick it up and run it?
The implementation.
Or is it just a dashboard? You know, the way you have Python notebook for Jupyter?
Yes.
Checking your notebook, somebody else can grab it. Can you do the same thing for Power BI, or is it just configuration on the dashboard alone?
Well, I'm not pro on Power BI yet, so I really don't understand what you're saying. But I just fed in the data here, transform the data, and then
It's more of a dashboard then.
So what?
I just yeah.
So it's more of a dashboard then.
It's
Yes,
a dashboard, yeah. Okay,
yeah.
all right. Oh, yeah, thank you. That's what I wanted to know. Thanks.
Okay, thanks.
Thank you very much, Oladimeji Williams. So moving on quickly to team Matplotlib, we have Sanjin and Oluwafobi Abraham.
Hello, am I audible?
Yes, you are.
Host, can you please make Sodic, can you please give Sodic the permission to unmute? Olufobi, instead of Olufobi, we have Sodic.
Yeah, I've done that now.
Yeah. Hello, good afternoon.
Yeah, afternoon.
Yeah, my name is Sodiq. My teammate is Sion Jane. We are the representatives of Team Matplotlib. So we'll be talking about used car price prediction using machine learning. Next. So the major problem we're trying to solve is to help car buyers and car sellers to be able to predict the prices of used cars who are probably they are not able to afford brand new cars, so they want to get used cars. So build a machine learning model that will help them to predict prices of used cars. Next. So we gathered 6 data sets from one of the 6 popular car brands. They are Audi, BMW, Ford, Hyundai, Mercedes, and Toyota. Next. So we perform our data analysis. We got the summary of our data sets, whereby we got the number of the rows and number of columns. We also cleaned the data sets, whereby we check for missing values and also dropped unnecessary columns that won't be needed for our machine learning, for our model. So next slide. So this visualization we're able to do on our data sets. We can see the price distribution of cars. We can see a decline in the price of cars. Also, if you look at the average car price by the year, which is an interesting visualization, we notice that the car price the price of used cars declined all the way from 1970 to 2000, whereby the price became steady for a little bit, which is from 2000 to 2010, before it starts to increase. This is probably because of the new innovations in cars. So I'll be handing over to my teammate, Tayo Jane, and we'll take over from there.
Now, after we move on to the feature engineering and model training step, after merging all the 6 data sets, we had a few categorical variables such as transmission, fuel type, and brand. So we applied a technique known as one-hot encoding. In one-hot encoding, all the variables are converted into numerical, so the machine learning model can directly read them. And after one-hot encoding, you can see that the categorical variables are converted into zeros and ones. So if it is manual, all the other fields such as automatic, other, and semi-auto will be 1. And the same goes for brands. On the model training step, we experimented with a few machine learning algorithms such as linear regression, lasso regression, decision tree using grid search CV. And after experimenting, we settled on random forest regressor as it gave us the highest accuracy. And by accuracy, we refer to the R2 score. And after that, we started working on the model deployment process. For the deployment part, we have created a web application, which is very user-friendly and easy to use. On the front-end side, we have used HTML, CSS, and Bulma, which is a CSS framework. And on the back-end, we have used Flask as a web framework. Now, the machine learning model was saved as a pickle file, which was very large, around 250 MB in size. So we compressed it using bzip2 compression algorithm, and which reduced the size to around 45 MB. That is nearly 4 times less than the original size. So at runtime, the model is decompressed. And when the user enters the details of the car, they submit the form, and then the form predicts the selling price of the car, and it is sent to the user. Now we'll show the live demo of a model. So we have got a Flask app hosted on Python Anywhere. And here is the form which the user has to fill in. Now Sodik, now we are going to pretend that Sodik has to sell his car. So Sodik, can you please tell me all the details of your car?
Yeah. So I'll probably want to get a car in the year 2019.
Okay, so 2019. What is the mileage?
Yeah, mileage should be around 3,934.
Okay. What is the tax in pounds?
145 should be.
145 pounds. Miles per gallon?
No, 32.8 is fine.
32.8. And what is the engine size?
Yeah, two is better.
Okay. The fuel type?
Petrol.
Okay, petrol. It is like automatic or manual or?
Automatic is better. I prefer
automatic. And which brand it is?
I prefer Toyota. It's probably strongest.
Toyota, right?
Yes.
Okay. So now, if I click on submit, you can see the selling price, which is mentioned in pounds. So, Sodik, your car should be sold for around 24,953 pounds. Now, for example, if Sodik had a Mercedes instead of a Toyota, the same parameters, and if I submit it, you can see that the car price increases by nearly 15,000 pounds. So the brand of the car is very important while predicting the price of the car. So this was our project. Thank you.
Interesting. Did you compare this with any of these car selling website? Like in the US, there's Kelly Blue Book. Did you compare your result to your prediction with other predictions on popular website where they sell cars and they do prediction?
No, we have not compared it on any other website as of now. But we have got in our future plans, we try searching for other data sets. Like here, we have only used these 6 brands, but we were searching for other data sets. Or maybe we thought we could we found 2 data sets such as cars sold on Craigslist or an Indian website called Car Dekho.
Exactly.
But yeah, the issue was that the parameters were not matching, so we did not merge them.
Okay, because what I'm trying to say is like if you take a car on Craigslist that was listed for sale, you can have all those parameters. You look at the selling price of that car on Craigslist, and you look at what your model is predicting. Are they correlating? Is it like good enough? So if you go back to your website
Yeah.
If you select, what years do you support? If you select same car, select 2010, and let's see what the price is. Because it's an old car, the price should go down. But the
Yes,
price,
it went down by 9,000 pounds.
it should go down before more than that. But this is good. I think you just need to improve on the feature sets you have in the model, and it will reflect. Because if I want to buy a car that was made in 2010, now in 2022 almost, the price would probably be less than that. But I think this is good. Good job.
Thank you. We this time, as compared to our previous project, this time we focused heavily more on the deployment, and we even tried to implement React.js, but we were having some issues like connecting React to Flask, where the page would not submit the data. So we just decided to use like a basic HTML, CSS.
Oh, yeah, I think this looks good. Did you use did you consider building APIs and web services? Then you can now use React to consume the API.
Yes, yeah, that's one of our future plans, to build like a general purpose API.
Okay, interesting. I want to follow up with you on that. Thank you.
Thank you.
So, how about you have anything?
Oh yes, very good job. I think it's a very applicable project that you all did. There are a couple of things that I would love for you to think. Can you still hear me?
Yeah, I can hear you now.
Okay, good. Yeah, there are a couple of things that I'd love for you to think about. The current architecture that you have, you have a bunch of data sets. How are you retrieving the data currently? Because I don't think I picked that while you were presenting.
No, actually, we have already done the we have done the training on a Jupyter notebook, and we have just saved the model as a pickle file. After saving it as a pickle file, since its size was too big, it was around 250 megabytes. So we compressed it using an algorithm called bzip2, which reduced the size to around 45 MB or so. So the model is pre-trained.
Okay, it's a pre-trained model. Yeah.
I mean, yeah, like we trained it and saved it to the using the pickle library.
Got it. Yeah, it'd be interesting to know. So there's a current trend in the used car industry where used cars, especially in America, and I think it's a worldwide thing as well. The used cars are more expensive due to the chip shortage. It'd be nice to see how your model reacts.
We have not tested it on that, but I believe that chip shortage, would it only affect electric cars?
No. It's affecting all cars at all, because it's a chip shortage. It's not just for cars. It's for all electronics. It's the same reason why your PS5 is not accessible, or you can buy it. You can't buy it easily. It's the same reason why used cars can't be repaired, because there might be a chip issue and you can't replace it. So that has raised the price, and there are newer cars aren't being made. So a lot of people are settling for used cars, and used cars are becoming more expensive. It would be nice to see how your model reacts to those sort of changes. But if it's a pre-trained model, I mean, it just really depends on when you capture the data.
Actually, we have got the data till 2020. So the data is just like a few months, an year old. We'll need like another year's worth of data, this year's data, to get it accurate.
Yeah, and it's more of how does your data react to supply and demand? How does your data react to seasonality? Because those are all of the things that affect outcomes of data in general, and the outcome of the price of the car in your case. This is good though. This is very good.
Thank you.
Yeah, you guys took it a little bit a step further, so that's awesome.
Thank you.
Thank you very much, sir.
All right, so great work, Sanyong and Olu for Abraham. So we're moving on quickly to the ML pack where we have Oge, Triumph, and Favor Adetunju.
Hello, can you guys hear me?
Yes, you're audible.
Okay. Good day, everyone. My name is Favor Adetunji, and I'll be presenting on behalf of Team ML Park on our project titled COVID-19 Diagnostics. Next slide. These are our team members, people involved in the project. Next slide. I believe we all know about the COVID-19 virus. The virus shook the whole world. It basically affected everyone's way of living. This slide shows some statistics concerning the COVID-19 virus. There are 5+ million deaths recorded. There are over 250 million confirmed cases. It all shows the magnitude of how this virus affected the world. Next slide. Problem statement. COVID-19 overwhelmed healthcare systems around the world, in particular when it came to cases that involved ICU support. Healthcare professionals were overstretched and overworked, and healthcare resources such as beds, ventilators, personal protective equipment, they were either short or unavailable. Now, the aim of our project is to solve this problem by using machine learning to predict if a patient will need ICU support or admission. This in turn will prepare hospitals with the information so that they could arrange ICU resources, or they could organize their workers, and if possible, even schedule a patient's transfer. Next slide. Now, this slide shows the different stages in our workflow. We first started with the data collection stage, then we moved on to data cleaning, then we did some exploratory data analysis, after which we did feature engineering and selection, and we finally ended up with model building and evaluation. Next slide. Now, our data was sourced from the Cargo website. The data was collected from 3 hospitals together and combined into one. The data contains anonymized data, and it was scaled from -1 to 1. Now, the data contains 231 features. These features represent the medical records of the different patients. And also, the data was collected over a 0 to 12-hour window, and it was spaced at 2 hours interval. Now, from here, we moved on to data cleaning. During the data cleaning step, we did activities such as dropping duplicate columns, checking for missing values and filling them, and we also drop unique value columns. Next slide. During the exploratory data analysis stage, we tried to find out how the data was structured and the relationship between these different features or variables. Now, this slide just shows some charts and some graphs on our findings. We had some key takeaways from this stage, and these are the key takeaways. First of all, we noticed that the class imbalance in our data set was little. We also noticed that the proportion of ICU admission according to the different windows, that is the 0 to 2-hour window, the 2 to 4-hour window, it varied largely. And we also found out that male patients and older patients above 65 were more probable to being admitted into ICU support. Next slide. Feature engineering and selection. At this stage, what we did was to select a subset of features that captured useful information for our model. We use different feature selection techniques such as quasi-constant variance and correlation. We also converted categorical features to numerical features in this stage. Then we also created new features such as we created a new target variable that comprised of only our final data. That is if the patient was admitted into ICU or not during the 0 to 2-hour windows. So during this stage, our whole data set now contained only the data collected during the 0 to 2-hour windows. The reason being we went through with this approach is that we thought that it would be better and more efficient if we could predict ICU admission earlier on than waiting up until the 6 to 8-hour window, 8 to 10-hour windows. So once patient is admitted with the 0 to 2-hour window record, we can easily predict if this person will need ICU admission or not. Next slide.
model building and evaluation. During this step, we first split our data set into train and test sets. Then we built different models and tested them against different criteria such as accuracy, precision, recall, and area under the curve. The table in this slide shows our results. After which, we also went further by using a sequential feature algorithm to further reduce our predictor features so that we could get more useful features to be put into our model. At the end of this stage, we came up with our best model being an extra tree classifier with an accuracy of 0.74%. Next slide. Now, the challenges faced during this stage were the team had little or no domain knowledge on healthcare systems, so it was quite a work on us. We had to research and do a lot of work on understanding our data. Then we also had the issue of time constraints. Next slide. In conclusion, we developed a model that can predict if a patient will need ICU support or admission. Next slide. Thank you for your time. Wear a mask and get vaccinated. Thank you.
Thank you so much. So on to our judges.
Bao, you want to take it off first?
Yes, hello?
Yeah, I can. I was munching something, so we're listening at the same time. All right. Overall, good job. I want to I still don't know can you go back to the conclusion slide? Because it seems like, did you find anything new beyond the fact that COVID affects a specific age group?
Part of what we, like I said earlier, we found out that male patients were more prone to being admitted into ICU. We also found out during our model building and evaluation, we also found out some features that really are useful for us to knowing if this patient will be admitted into ICU or not. So those few features now, it can be quite useful to hospitals also. With little features, that's when I mean features, I mean medical tests and record. We can actually find out if this person would be admitted into ICU or not.
Yeah. Are these features that are not public knowledge already?
I believe they are public knowledge.
Yeah, because the reason I asked, and sorry that I'm cutting you over there. The reason I ask is because I say I know, and I would imagine at least 80% of the folks on this call know that older people who are obese, people who have underlying health conditions are susceptible to being in ICU and admitted to ICU for COVID-related illnesses.
Okay.
That's no new news. The whole purpose of taking data is finding out something that everyone else haven't found out, or making some validations, but with a different twist. So my challenge to you is to find the uniqueness about the analysis that you've done, that will be something new to us. And I don't know if you've shown it.
I don't know. Please come again.
So I don't know if I've seen it throughout your presentation. Like,
okay.
I don't know if I've learned something new.
The thing is that apart from what I said, we also found out some other things, like some disease groupings that were our key notes in someone being admitted into ICU. But the whole reason why we couldn't really find out more was because this our data set to work with. It was anonymized, as in the features were hidden. Already it was pre-scaled, and most of the features were hidden so that you could protect the patient. So I can't really say much about that because I don't know what the real data wasn't really accessible to us.
Can you go back to the feature list and let's look at what you're talking about? Because you can anonymize the data without, you can expose the features without revealing the patient.
I'll go to model building.
Yeah, let's look at your feature sets.
Can you zoom in? This is bar graph is the important features that were good for our model.
Okay. So I think back to what Piotr was saying. I mean, you can see, I mean, age is a component of this, and a lot of all those things, you probably needed to do more research on it. Like someone that is obese will likely have maybe high blood pressure. There's a correlation between that. And all these things, they basically have their medical interpretation. So a doctor will probably be able to like infer and see how this correlates between like any underlying condition. So if you have a respiratory problem, it probably will affect your respiratory rate and all those things. So I think those are the research you should have done in addition to your work, because one of the things you're trying to do is not just to analyze data, but to understand the domain. So you need to like maybe talk to doctors, understand what a PCR median is, understand what will cause a patient to have a low respiratory or high respiratory rate, the at rate, what's the implication of that? So all those things are indicators, and you can map those indicators to any particular underlying condition. So that way, your model can validate that. If someone is obese, if someone is a smoker, they're more likely to, so they're more susceptible to be admitted in the hospital for COVID and things like that. So those are the kind of things that make sense to like normal people like us who are not doctors, but all these indicators and the features you have in there, they're things that doctors look at, and they can know without telling them that this patient is probably overweight or he has a particular underlying condition and stuff like that. So all those things are probably the research you should have done, and talk to a doctor or just understand all these things from that perspective. So that way your model can make a lot more sense. And no, because these are people's lives. Not really, it's not data. So whatever decision you take, whatever, and I'm telling you from practical application, whenever you build a model, people use it and they believe whatever comes from the model. So you should be able to like understand the problem a little bit more deeper and be able to make good recommendations. It's very, very important. Good job overall. Sorry for hijacking your time, Val. Do you have any more comment?
Oh no, not at all. No further comments. But yes, to Charles' point, this is an example of what I was asking for. If you could dig deeper into this, because at the end of the day, you're doing an analysis, but if your analysis is telling people what they already know, then they will say, okay, thank you very much, Captain Obvious. Like this is something that the WHO has already told me. But if you're telling people something new, they're learning from the work that you've done. Someone else can take that work and do something else with it. So that is that's what I'm trying to push you to do. Look at the data and ask yourself, have I learned anything different? Or has the person next to me learned anything different? And if they have not, maybe there's an opportunity for you to dig a little bit deeper and create something, or find something that's unique. That becomes part of what you have done or contributed to literature or research, if you will.
Okay. Do that.
I think that's it. We can move on to the next question. Thank you.
All right, thank you very much, Triumph. So we have the next group, Team Pandas, and lastly, we have Team Plotley. So just on the ground. So for Team Pandas, we have Chukuma Anthony Wanchuku as the presenter.
Hello, can everyone hear me?
Yes, you're audible.
Okay. Representing three. So, through organization distribution.
Sorry, I think your network is breaking. Could you be more clear?
Can you hear me now?
Yes, it's better now.
Okay. Sorry. So, population, we defining what population is first. So, population is just basically a group of individuals or the same species living a specific area. From our project, we were asked to define or to predict population over a span of years. That is plan for the future years. So we're supposed to do the prediction on a human population exactly. So for that, we got our data set from World Bank. The World Bank. Most of our data sets we had to clean it off and we focused on some major, should I say, features that we thought would yield more fruit, or should I say that affected population more. So for us to do that, we had to fill our data set, had to fill the no values using the forward method, because it's generally a population data. I mean, most of the data of previous years would match the ones in the should I say previous ones before it. So use the forward fill method to fill up our null values. We focused mostly on population growth rates, crude death and birth rates, and believe that this will affect the increase or decrease in population over a span of time. And while we did that, we noticed for us to do that, we had to sum up most of our data sets, because most of our data sets were split into countries. They are split into countries. So in order for us to better get an accurate prediction of to get population estimates of the world, so to say, we had to sort out those countries to several regions, like we sorted out to Africa, Europe, and some other stuff. Summed up the countries in those locations, and we did an estimate on those locations to get the population rates in those regions. And after we did that, we noticed something. The population, the world population has been increasing since the 1960 up to close to 7.9 billion as of recent, and found out that also the annual population growth rate as opposed to as opposed to other years has been decreasing. That means that the average rate of change of population size has been decreasing. As the years go by, the population increase from the previous years is not so much, but it's been going down gradually. We also found out that the growth birth rate and the growth death rate has been on the low. That is, to have lower, or should define what death is. That is the number of data over the population at a specific period of time. I mean, a lot of people buying, people being given back to it's going low, or it has been point recently. So after we did that, to compile our data into our population density to figure out what locations had more location as opposed to others, and we figured out that Asia had the highest population distribution. After that, we moved on to our analysis and model creation. during the process of data, we had to consider some models, AR, ARIMA, Prophet, and some thought exponential focus in order base our models of this. And we'll use metrics such as MA, PE, and RMS, E to base off our to get which models will be best appropriate to use. And you could see from my presentation or from my slide, if you have them on you, we had checked some of trend and seasonality rate on every single one of our data sets, on every single one of our focus features being the crude birth rate, crude death rate, and annual population increase. So we did the trend and seasonality from it, from crude birth rate. We also tried out some models on, as I mentioned, we tried out so many models, most especially the AR models, ARIMA models, exponential focus, and Prophet. We use our metrics here, as you can see. Our metrics here being MAP and root mean square to get what stuff was what models were most appropriate. And I will just skip over, as mentioned, did everything there. Both on the crude birth rate, the crude death rate, and the rest of it. So at the as you can then on our annual growth rate, we did the same thing there, finding out, trying to figure out which model will be most appropriate. And for us to know for the AR models, we had to try out our ACF and PACF plates to know what AR models would be most appropriate, or should I say what time splitting models were most appropriate. So after we did that, and we were able to figure out what models we are appropriate on each of them, we did tried out our word population, like to sum up all of our data to our word population and to see what those combinations will give us. So we differenced our data because our word population data was non-stationary, sorry. So we differenced our data, then on difference the data, then run our ADF should I say metrics on it, and afterwards we figured out that some models were, should I say, most appropriate for our crude death rate. We figured out that our crude death rate, we figured out our Hertz exponential models were most appropriate. Crude birth rate was most appropriate, word population, and so on and so forth. After which we now did our predictions based off of those model combination. As you can see, we figured out that our word population between our annual growth rate from 2020 to 2060, we figured out that our annual birth rate, annual growth rate, sorry, which has been on the low since 2020, will keep going down likewise, or just keep descending to the next foreseeable future. We figured out that our population estimates, should I say, our projected population to 2050, we figured out that our, sorry, I don't know if you guys can see because of this. We figured out that our what population forecast will be increasing after it has been on the increase since should I say 2012 or should I 2008, and continue increasing towards 2000 and should I say 45, then be a stable trend afterwards. Then we checked out our crude birth rate. We noticed a slight slope towards our 2020, which has then our crude birth rate will be increasing little by little towards the next foreseeable future. And we figured out that our death rate too. We figured that our death rate will be on the decline because of improved technologies and the rest of it. So from this, I already explained most of what our plots were, and from our data set, we would have much more appreciated if we had more data sets relating to sorry, we had much more data sets relating to our relating to the GDP of the countries, natural disasters, some other stuff such as, should I say, to figure out if national disasters, if the country is wealthy, if the country has much interventions from external forces, if there will be war in the next foreseeable future. If we had more data set relating to those things, would have been, should I say, better predicted our models. But from our results, we're able to figure out that our model prediction, or should I say, our population estimate over time, correlated to that of the UN. Because we compared our results to that of the UN and figured out that it correlated with it. And afterwards, we deployed some kind of a blog, something to explain what the whole process we went through to get our data and some information regarding our results. Thank you very much. Joyce, I will just post the blog right now, if you let me. Okay, this is what we did. Afterwards, found out that our data correlated. Basically, almost everything I just explained, and that was just it. And we did some world population forecast over the years to seeing the yearly change. That is our annual growth rates and CBD, CPR in our growth rate and CDR. You see the predictions as it goes down towards the years. So thank you very much for.
Yeah, I mean, I was having a lot of technical glitch on the side, so I don't know if Bao, you picked up things a lot more.
Yeah, I had some technical issues here too.
Yeah. Is there anybody on the group that can take it up and explain stuff if we have questions? Are you the only presenter?
Yes, sir.
Okay. There's a little bit of glitch, but I just want to, if we can explain, talk a little bit about your modeling a little bit.
Okay. As I explained, we tried out our modeling on some AR models, Arima, and some AR that we tried out. It was also exponential forecast. That would be perfect. So let me see if I can
the audio is not there. It's a little bit worse.
Sorry?
The audio is not good.
Oh, my audio.
Yeah.
Oh, I don't know. Can you hear me properly now?
It fades out a lot.
Oh, sorry. Hello.
Man, why not this? So we can keep going. So one thing I'll do is I'll go review the slides, and if I have any questions, I'll post it to you. Unless Bio has any questions.
Okay. Okay. Oh, sorry.
All right, thank you very much for the presentation. So moving on to our last presenters for today, we have the group Plot Group presented by Adedamola Adesoye and Louis.
Oh, hi. Good day, everyone. Please can we grant John Kennedy access to share his screen? Okay.
Yes.
Thank you. Hello, everyone. This is Team Plotline. I'm Lois Wakili. So let's talk about food for a bit. We all know it's a universal necessity. And for some people, it's a means of retaining their cultural identity. And it even goes further beyond that to actually touch other people in different ways, like their spirits and their souls. And now, the aim of this project will be to use a machine learning approach to classify cuisines. To get to this, we followed a proper machine learning procedure, which we had to get data from all of these sources you see here. And then we also went forward to see what our data look like. And then you can see a number of ingredients in our columns. And then we have yes and no's to represent the ones and the zeros in our data. Now, moving forward to do some exploratory data analysis, we did discover that we had an imbalance in our data. We had most of the recipes come from North America. And we also did see on the next slide that there was an average of 8 ingredients per recipe for every country present. So this actually helped to make more informed decisions moving forward. Have a look at this sunburst chart and see how these ingredients have been distributed. You can see that garlic takes up 48% of the of South American dishes. And then digging deeper into any of the continents like Africa, for instance, you can also see various food proportions and how they are being distributed in terms of percentage. We went further to do some feature engineering, which involved having to encode our data. So we had to get the yes and no's to ones and zeros so that we can actually perform some machine learning with it. We also did sampling because we did say we had imbalanced classes. So we had to oversample the minority class using IMD learn, and then we got it to match a close estimate to the majority class. And then once we did that, we were clear to go ahead and use our machine learning models. So these are the models that we actually used. We went with ensemble techniques, tree-based classifiers, as well as a neural network model, because they have proven to do quite well on a first try. And you can see the results we got from these. You can see that our extra trees classifier did really well. We made sure to check train and test accuracy just to be sure that we are not overfitting in any way. And we also took precision and report scores to see how each of the classes performed individually. Now we go ahead to show you a demo of a web app which we designed to actually predict these cuisines. So it's a simple interface, and once you open it up, it gives you the option to select the number of ingredients. And then when you enter these ingredients and you hit the predict, that gives you the cuisine it is. So we're just going to go ahead and put a bunch of random ingredients that we want to. And you can see that we put a constraint that limits the number of ingredients to at least 7, because when we explored the data earlier, we could tell that 8 was the average number of ingredients that each recipe or each cuisine, contained. So to get a prediction without error, we had to have at least these numbers. So we've got some egg, cocoa, butter, some peppers as well. And then when we hit our predict button, we can see that it tells us this cuisine is American. So you can actually try and add or change some of the ingredients there, and then you can get some results as well. I would say, in conclusion, it's actually really possible to be able to classify cuisines based on the ingredients that we give it to them. And like I said earlier on, lots of people's cultures really rely on their meals, which is part of their identity. And so being able to correctly classify these helps preserve their cultures and just gives these people a sense of belonging. For future work, we actually intend to be able to make our web application have a prediction accuracy or confidence level, And we also would like to see a lot more Nigerian or ingredients like ugu leaves or palm oil, because they were not present in the data we got. And then hopefully, when we decide to work further on this, we can have something that is very native to us. Thank you so much. I hope you've enjoyed that presentation. This is Plotline once again. I'm Lois Wakili, and John Kennedy was behind the scenes. Thank you.
Okay. Yeah, I think the presentation looks good. I mean, it was well presented, but I just want to get into what was done. So the whole purpose was to predict where a particular cuisine came from based on the ingredient, right? And
yes,
it's not. So what would that do to me? I'm hungry, I want to eat. I don't really care where the food came from, but what does this do? And how can you make it, what value does it have to me in terms of, I'm very hungry, I want to eat right now. I don't care where the food comes from. What's the application of this?
Okay, that's interesting. So in terms of application, I do see a situation whereby we get like a lot of developers interested in actually trying to make Nigerian-based recipe websites, because those existed, and then we got this data and went ahead to do that. So that would actually help. And I feel like a lot of people get some satisfaction knowing, what particular ingredients make up what they eat or where it comes from, because there are times that we mistake Spanish for Mexican meals because of similarities amongst these two. So having something like this would actually help in a way. And most especially, it's just about cultural preservation, which is really important to a lot of people.
Mm-hmm. Yeah, so one area of application I see a lot is some like you go to some places that do things like Afrofusion. So instead of doing it this way, where you're trying to predict where a cuisine came from, can you recommend something for me based on what I feel like eating? So if I feel like eating, let's say, Nigerian food, I want to get a recommendation based on the recipes or what I like in my food, or if I'm interested in Italian or Mexican, I want to get a recommendation. So that way, if you build a website, if I'm trying to search, if I put in the cuisine or the place where I think the food comes from, I should be able to get some good recommendation based on that, instead of going the other way around, where you put all the ingredients and you now predict what the cuisine is. Because I'm looking at it from utilization perspective. People care about the food, but not what makes the food. So
that's a good point. Looking at it from the back, coming all the way up, that will actually be quite a different direction for the main aim of the project. We did think about having to predict like recipes. So you put in what you want, and then it gives you like, okay, this is what you can make, for instance, chicken salad or something. But it didn't seem feasible. And then this seemed like something we could accomplish, as well as would actually make some sense. So that is very important. I'll be sure to make a note of it if, for instance, we want to diversify going forward.
Exactly. And the other thing is, like, some people have allergies based on the ingredients. So you might want to look at it from the perspective of, okay, if I'm trying to eat this kind of food, you understand the underlying ingredients, and you can basically recommend what I can eat based on my allergies. So we can map a particular ingredient to the allergy type and be able to predict or recommend something for people. I'm just trying to look at this in terms of the usability, because you guys have access to the data, but how can you make this something of value to the average Joe on the road? Because the average Joe will not go in and punch all the ingredients he wants in his food. He wants the food and he wants you to like recommend the food type. And that's the way the normal human brain thinks. So my suggestion would be to look into areas of application. You guys have done a great job basically wrangling the data, presenting all this, but at the end of the day, whatever you do, someone needs to pay to use it. So if someone is not paying to use it, then it's not a product, it's not fun. So that'll be my recommendation. So try to see how you can make it more applicable to people's life, which is a lot more important.
Sure, thank you.
Sure. Yeah, good job, though.
Thank you.
Yeah. Bob, you want to pick it up?
Yes, I do. I really like the project that you all have done. I think it's a it's applicable. And I compared the project to something similar to what we saw with the cars. There are multiple.
Your partner as well.
Yeah, there are. Say that again. I missed that.
I think somebody should. There's a background noise from someplace.
Okay, yeah, there is a bit of background noise here, so you just pardon me for a tiny bit. I will speak a little louder. What I like about the project is the fact that you curated the data such that it's digestible. The user experience for what you have done is still a little bit wonky, but here's how I would like for you to think about it. I have a pantry. In my pantry, I have all these dry ingredients, or maybe some some liquid ingredients as well. And I could say, all right, I want to do American, and I have these 5 dry ingredients. Present me with an option of what I can make. That makes the data set that you have created a little bit more fun.
Yeah.
In that way, you're connecting with the outputs even before you have the full input, if that makes sense. There are multiple variations of how you can take the data. Obviously, if you can also make this in such a way, if you can create a data ingestion type pipeline that makes it easy for Africans or Africans, Nigerians, or all parts of the continent to create their own ingredients or create their own recipe, and have it all ingested into your data sets, that would be awesome as well. But overall, I think, I like the direction that you're going to, and anything that works, any project that democratizes data, it's always good.
Sure, thank you.
You get my point as to you have a pantry that has a bunch of ingredients, but you know exactly what you want to make, which is African American, and then you want to connect the outputs and use it as a way to query all of the ingredients that's available, all of the recipes that's available within your data set. Doing that makes it a little bit more fun. It makes it more of a place where people want to come to just experiment.
Yeah, that is correct. Both of you have said the same thing, so it's worth considering. So thank you.
That's good. You're welcome.
So thank you, Lois, as well as your partner, for the presentation. It was actually very interesting. So before we wrap up, we'd like to call on our judges one last time to give a recommendation on how to move forward with the presentation and how they feel we could learn or present better. So Mr. Biodun.
All right, yeah, just trying to get my own mute button up. I like the direction that you all are going. The one area that I've seen as a trend across all of the presentations is you need to work a little bit more on the applicability to real life. Make this more of think about it as, how can this lead into a product that people don't have to pay for it, but a product that people can use, because the moment they use it, the more I think you find a lot of value in people using your product, people finding a need to continue to come to your site because they realize that you've built something that's applicable to all. It's from the car, the used car or new car repository that's been created. It's in the ingredients. It's in the COVID test. It's how can we, or the COVID examples or the COVID project that's been done, how can you create a platform or a solution that people can come into and find easy, useful, digestible information from? Also, I mean, if this is your first real project, look closely into blogging about it. And when you think about blogging about something, obviously you need to be thinking about why would anybody care to read it? If it doesn't have, if it's a, what is the so what of my project? You know, I have COVID results, so what? I have some, is this saying the same thing as WHO? If it is, then maybe I'm not adding so much value. But am I creating something? Am I creating a niche? Am I creating another angle or another way for someone else to look at things? I know it is easier said than done, but I would say the first way to start is doing the project. The next thing to start is creating a community of people that can help you critique the work that you've done. But overall, I'm very impressed with the quality of work that I've seen. And I mean, I can't wait to see see your blogs once it's been published. If you publish anyone, please feel free to send it to me. I'll pass it on to you, Charles.
Yeah, I think you nailed it. So I'll just echo what you just said. Overall, you guys are trending in the right direction. Or the fact that you were able to like do this at the end of this whole program shows that you've basically learned a lot. But like when you get to the top of one mountain, I think you should not settle down there. There's still another bigger mountain in front of you. So that should be your goal, and trying to make sure you improve on yourself from there on and do a lot more than you've done. So you understand the basics right now. You're doing probably your first presentation. But think about this down the road, maybe 5 years from now, you're making this making this presentation to an investor, or you're trying to make a pitch. It's not just data, it's things that will affect people's lives. So you want to make sure you have your numbers right, your presentations are right on point. I understand there could be some technical glitch right now, the way you present and how you present, but all those things are things you need to clean up down the road and make your presentation crispy, straight to the point. Let your numbers talk for you, make sure you've done your research. Make sure you understand the data and understand the applicable use case, because that's the whole goal. If you're building something, it's not just research that will be done somewhere. What you're building tie into people's life. It's life and death for some people in some cases. So whatever model you're building, whatever pipeline you're using to like train your data, your results should be very accurate and precise. So all those things are what you can work on. And I'm confident most of you guys will get there. So just keep improving on what you've done. And if you guys have any questions or want to keep working on this and extending it, stay connected to your peers in the group and reach out to everyone here. And we'll see how we can keep getting this going, pushing this in the right direction. But overall, great job. And I'm really impressed by the quality of work so far. Thank you.
Yeah, great job, guys. Like from the recommendations and from the pointers from our judges, try to blog it as much as possible. Try to make your work accessible to others and try to communicate as well. I must say it has really been an interesting presentation. Personally, I'm excited with the level of progress you'll have made using data-driven techniques to profile solutions that are really important in our society today. Before we wrap up, I would like to remind us of our next week's presentation, which will be like the wrap of this presentation. And we have some groups that will be presenting. We have, just to call the names, we have the group Prophets, we have PyTouch, Skype, we have Scrapey, we have Scikit-learn, Seaborn, and XGBoost. So we indulge you guys to prepare very well for this presentation next week. So thank you guys for today's presentation. It was really interesting. I really commend the presenters for this wonderful presentation. I also won't fail to commend our wonderful judges. Yes, I would like to emphasize that always. Like, it has been really, I learned personally from your pointers as well. So also a very big thanks to the members of the Hamoye AI Labs team, who've been instrumental from the beginning of this internship to make sure it was a success. And to everyone who has stayed up to this point, you all are the MVP. So thank you and have a wonderful weekend. Bye, guys.